Section 5.2, example 8, using algebraic properties of convergent series. So let's take a look at this. When we look at this infinite sum, just like limits, just like integrals, we're able to break these up into two different parts. So we could start off with that. So the sum as n goes from 1 to infinity, n times n plus 1 over 3 plus sum as n goes from 1 to infinity of 1 over 2 and minus 2. So separating those two there. Earlier in the previous problem, we saw that this ends up going to 1. So we could break that up. So for this one, we'll say the limit as n approaches infinity of n plus 1. Actually, no. This was a sum. So this was 3 times s of k, where s of k, we did something a little bit different. Let's work with this one. S of k ended up being, what was it? K over k plus 1. So we could take the limit as k approaches infinity. So 3 times 1, this ended up being 3. Now let's work on this one over here. This one here is a geometric sequence where we have the first term. So the sum of the infinite sum of a geometric sequence is a1, 1 minus r, our common ratio. Our common ratio is 1/2, so we have to figure out what a1 is, and we just plug 1 in here. So 1 minus 2, that gives us -1. So we have 1 over 2 to the -1, which just equals 2. So we have 2 over 1 minus 1 over 2. And we can multiply both top and bottom by 2. We end up with 4 over 2 minus 1. And 4 over 1, which ends up just being 4 there. And now that we have these two separately, we could just add them together. 4 plus 3, or 3 plus 4 gives us 7. So the infinite sum converges to 7. So converges to 7. And there we go. A bit strange, but we ended up getting to the final solution. If you have any questions, please feel free to ask. Otherwise, bye.